In this lesson, we look at ridge regression. The idea behind ridge regression and lasso is to fit a model with all p predictors using a method that constrains or regularizes the estimated coefficients or shrinks them towards 0. Doing so reduces the variance. In OLS, we are trying to find estimates of the coefficients that minimize sum of square errors, which is that expression. In ridge regression, we try to find estimates of betas that minimize this expression there. So, the first portion of the right hand side is sum of square errors, and the second portion is what we are going to look at. So, lambda is a tuning parameter which has to be determined separately. We will discuss that shortly. The second term, lambda times sum of the beta squares, is called a shrinkage penalty. This penalty is small when the betas are close to 0, and if lambda equals 0, the ridge regression essentially produces least square estimates. As lambda becomes very large, the penalty impact grows and the ridge regression coefficients go to 0. Note that each value of lambda in ridge regression will get you a different set of these beta coefficients estimate. In ridge regression, note that the penalty does not apply to the intercept term beta 0. It is best to apply ridge regression after standardizing the predictor variable, that is, dividing each predictor variable by its estimated standard deviation, so that all betas are on the same scale. The bias variance trade-off comes into play as you vary lambda, and the test mean square error is a function of the variance plus the squared bias. So, when lambda equals 0, the variance is high, but there is no bias. As lambda increases, the shrinkage of the coefficients leads to a reduction in variance of the predictions, but with some slight bias increase. So, we have taken a quick look at ridge regression. We now next look at lasso.